All right, so example number 3 is in factored form. So when you're in factored form, you can find the zeros or those x-intercepts real easy. Remember, the x-intercepts are x equals the opposite of what you see in these parentheses. So x equals the opposite of what you see. So my zeros here are x equals 4 and x equals positive 2. So those ordered pairs are 4, 0 and 2, 0. So go plot those. So I'm going to go over 4 up 0 and over 2 up 0. Those are my zeros. Now, what do we know about the axis of symmetry? When I'm in factored form, remember that axis of symmetry is halfway between those zeros. So if you can't look right there and tell that it's x equals 3, remember your little formula is x equals p plus q divided by 2. So you're taking the average. So x equals 4 plus 2 divided by 2. So 6 divided by 2. So that's where x equals 3 comes from. So x equals 3 is that axis of symmetry. So I'm going to come over here and I'm going to dot my axis of symmetry. Now you can't just go in there and put what you think would be the vertex. You have to go find that vertex. How do you find the vertex? You plug your x value into the place of x and solve for y. So if I know my axis of symmetry is x equals 3, I know my vertex is going to be 3 comma something. And that something we're going to figure out when we plug 3 in the place of x. So f of 3, that just means I'm plugging 3 in the place of x in the equation. I'm going to work it out. So 3 minus 4 times 3 minus 2. 3 minus 4 is negative 1 times 3 minus 2 is 1. So negative 1. So when x is 3, f of x or y is negative 1. So my vertex is over 3 down 1. Now I can tell that my parabola is opening up. Well, remember that a value, that number in front, is a positive 1. So my parabola is opening up like it needs to. Now that's really not enough points for me to plot my parabola. I really need a couple more. So I'm going to go in T-chart. And I already know that my vertex is at 3, negative 1. And then one x value away from that is 2 and 4. And when I plugged in 2, I got 0. When I plugged in 4, I also got 0. We didn't really do that work. Those are our zeros. And if you'll notice, that y value is 0. So now I'm going to go 2 units away from my vertex, which is going to be positive 1 and positive 5. And I'm going to plug into my equation of f of x equals x minus 4 times x minus 2. And I'm going to find a couple more y values. So when I plug 1 in, 1 minus 4 times 1 minus 2 equals, and I'm just doing this work, 1 minus 4 is negative 3 times 1 minus 2 is negative 1. And negative 3 times negative 1 is positive 3. So when x equals 1, y is 3. So I'm going to go over 1. Let me pull that down just a little bit. So when x is 1, y is 3. So I'm going to go over 1 up 3. And then I'm going to plug 5 in. And I should get the same value because if I mirror that across, notice I'm at over 5 up 3. I should get 3 for the y value when I plug 5 in. Let's see if that happens. So 5 minus 4 times 5 minus 2. 5 minus 4 is 1 times 5 minus 3 is 3. And 1 times 3 is 3. So over 5 up 3, and I have a parabola opening up like it's supposed to. And if you want to know the y-intercept, which is actually another value, another point that you could find, that would be me plugging 0 in the place of x and solving for y. So I'm just going to do that. 0 minus 4 times 0 minus 2. I get negative 4 times negative 2 is positive 8. So when x is 0, y is 8. And I actually don't have enough y values up here to be up here somewhere. 1, 2, 3, 1, 2. So I'm going to mirror that across. And that's plenty of points for you to plot your parabola. So connect those ordered pairs. And you have that right side of the parabola.